Hi everyone. Today we talk about the solution to problems 3.83 and 3.84 in page 114 in Chang's Chemistry 10th edition. Problem 3.83. Nitric oxide NO reacts with oxygen gas O2 to form nitrogen dioxide NO2. In one experiment, 0.886 mole of nitric oxide is mixed with 0.503 mole of oxygen gas. Then you are asked to calculate which of the two reactants is the limiting reagent and to calculate also the number of moles of NO2 that is produced. This problem involves stoichiometry. Reviewing the definition of stoichiometry, I got these definitions from different websites. First definition, that stoichiometry is a section in chemistry that involves using relationship between reactants and or products in a chemical reaction to determine desired quantitative data. The other, it is the quantitative relation between the number of moles and therefore mass of various products and reactants in a chemical reaction. Going back to the problem, what are the given data? So we are given the balance equation and we are asked for number of moles. This problem can be solved without having to use a calculator. Why? Because the relationship is quite simple. Take note. Okay, from the balance equation, we know that 2 moles of nitric oxide will require 1 mole of oxygen gas to produce 2 moles of nitrogen dioxide. So, claro, the relationship is 2:1:2. So if you are given 0.886 mole of nitric oxide and 0.503 mole of oxygen gas, obviously 0.886 mole of nitric oxide will require half this amount in mole of oxygen gas, 0.443, kasi 2:1. And if you are given 0.503 mole of O2 times 2, kasi 1:2, will require 1.006 mole. Kaya balikan natin, if this amount will require 0.443 and you are given 0.503, sobra. Okay. And if this amount requires 1.006 of nitric oxide and you are given 0.886, kulang. So, ibig sabihin, this one is the limiting reagent and this one is the excess reagent. So, where do you base your answer? Sa product. In the product. You base it in the limiting reagent. Again, take note of the relationship. NO is to NO2, 2:2, or it is also, if 2:2, it's just like 1:1. Okay, so if you are given 0.886, kasi ito yung limiting reagent natin, you will also produce 0.886 mole of the product NO2, nitrogen dioxide. Dito naman sa problem 3.84, this time I'd be using a calculator. The problem goes, the depletion of ozone O3 in the stratosphere has been a matter of great concern among scientists in recent years. It is believed that ozone can react with nitric oxide that is discharged from the high-altitude jet plane. The reaction is given O3 plus NO will produce O2 and NO2. Okay. If 0.740 grams of ozone reacts with 0.670 grams of nitric oxide, how many grams of nitrogen dioxide will be produced, which compound is the limiting reagent, and calculate the number of moles of the excess reagent remaining at the end of the reaction. Okay, so I made some arrangement of the question sequence a little bit because I cannot get to answer this question without having to establish first the limiting reagent. Okay, so going back, this is the balance equation. Since we are asked for mass this time, and the given is mass, grams, we need to establish the mass relationship. So O3 molecular weight is 48, NO molecular weight is 30, O2 molecular weight is 32, and NO2 molecular weight is 46. You will know if your mass relationship is correct because if you sum together the masses of the reactants, that will be equal to the masses of the product. Now, since this is a stoichiometric relationship, ratio proportion. Okay, so the ratio between ozone and nitric oxide in terms of mass is 48:30. Okay, so we carry out proportion computation using the given, ito muna, and then this one. Okay, so for ozone first, the ratio is 48:30. 0.740 Compute for x, you will obtain 0.4625. But the given is 0.670. So obviously, yung nitric oxide is in excess, okay? Because the reaction requires only, the reaction with 0.740 of ozone will require only 0.4625. Now, we need not carry out the next computation, but just to counter check. So we do the same with nitric oxide. The mass relationship is 48:30. 0.670 grams of nitric oxide is to x grams of ozone. Okay, computing for x, it's 1.072 grams. Ibig sabihin, this mass of nitric oxide will require 1.072 of ozone. Pero, ano ang given sa ozone? 0.740 lang. Ibig sabihin, kulang. So, ozone is the limiting reagent. Nitric oxide is the excess reagent. So, if we are going to compute for the mass of product, we base it on the limiting reagent. Okay, so the relationship now is 48 of the limiting reagent is to 46 of the product. 48:46. X, what amount of the product will be produced? X is to 0.740. Computing for X, you will get 0.709 grams. The next is to calculate the number of moles of the excess reagent remaining at the end of the reaction. Okay, so earlier we know that only 0.4625 grams of nitric oxide is required for the reaction. Sobra naman ito. So merong maiiwan. Okay, so if we subtract this from the initial amount, 0.670 minus 0.4625, ito yung nag-react. Ang maiiwan na unreacted is 0.2075 grams. But since we are asked for moles, calculate the number of moles of the excess reagent, we need to convert this first to grams. To moles, sorry. To moles. We convert this first to moles by dividing it by its molecular weight. Ito. So 0.2075 divided by the molecular weight, which is grams per mole. The gram units will cancel out. Ang maiiwan na unit is mole. That is 6.91 times 10 to the minus 3 mole. That is the amount of nitric oxide in mole that will be left behind.